So, hello everyone, and welcome to Unacademy classes. My name is Abhishek Mishra, and in this class, we are going to do important questions from the topic drilling. This class that I will be taking right now will be specifically dedicated to drilling questions, and we have done some drilling questions before, but this class is entirely going to focus on that topic. So we will cover some good questions from the GATE exam itself, and we will cover questions from outside the exams, which are not that much, but because I have accumulated the questions that are from GATE. I have also accumulated some conventional GATE questions that are a bit lengthy, but they are very good questions which will definitely clear your concepts. So, as always, in the class, you will be seeing important tips and tricks, some potential mistakes. We will discuss that also, and we will also uh, see that by following what approach we can do a question without making errors, or without having the probability to make errors, and without having uh, just without taking a long time. So we will be taking care that we are discussing that approach also, and this class will entirely be in English so that a lot of students can answer that, just understand this session. And we are obviously going to learn the topics, learn the theory in English only, so it is better that we continue our discussion in that language only. And let's just begin the class. But before that, about me. So I have secured All India rank 662 in GATE 2020. I have completed my MTech in 2019 from IIT BHU Varanasi, and I have got a good experience of teaching 2 years in uh, teaching 2 years mechanical engineering subjects. And some of my interests are listed here: photo editing, video editing, cricket, football, and I like all sorts of games. So since you can see in the screen that I have both prepared for GATE and taught GATE examination, therefore I have accumulated a number of things that I think if I share with you, you will find them very beneficial, very helpful for your GATE exam. So I will be doing that in this class, just like I have done in my previous sessions. So Unacademy's learning app is free to download. So just download this app, and you can see what this app offers by just going through the respective app stores and downloading it. And since this app is free, so there is no harm in checking it out. And if you check this app out properly, you will find that this app is very beneficial thing to have. And this app is just having all the things that is necessary for your GATE exam preparation. So name one thing which you require for your GATE exam preparation, and this app has got it covered. So upcoming classes, scheduled classes, recorded archive classes, test series, your analysis, structured courses, live test and quizzes. So everything that you need, this app has it. So just download it and just use this app for your preparation. And in the screen you can see the benefits of, or what you will get when you subscribe to Unacademy. So Unacademy is asking a very reasonable price for the amount of content and the quality of content and the advanced tools and things that they are offering. So first of all, just download their app or visit their website and see how properly designed, how carefully planned their website and app is. It is made by keeping in mind that a student here comes to study, and what he or she needs is properly taken care of. So if you just see YouTube and compare the YouTube video player or YouTube just sites interface with the Unacademy interface, you will clearly see that YouTube is just not that good for educational purposes. because it is not having the uh, tools and the proper interface for the learning. So Unacademy, when you subscribe to Unacademy, you will be getting daily live classes, and those live classes you can in those live classes you can ask your doubts, answer polls all while the class is going on. And this is only made possible because of the amount of interaction that those websites, Unacademy's website, offer, which is especially not the case for YouTube. And live test and quizzes are also there for you to evaluate your performance with regular test and quizzes. So regularly new content, new test will be added, and you will be getting a detailed analysis on your performance also. And structured courses are there, which is in line with the exam syllabus of yours. So this is done to make you prepare in a progressive manner and in a manner which creates a rhythm, which is very important for your gate preparation, because you will be studying for a long number of days, and each day you need to be well energized and motivated to prepare. And the structured courses will just keep you fresh, keep you just going in the right direction. And unlimited access of content is provided. So if you are going to subscribe from today, then not only you will be getting content from the day onwards that you have subscribed, but you will also be getting content that has already occurred, classes that has already occurred. You can just go and watch them, and just attend any classes that you want. And top educators are hired by Unacademy. So as I have mentioned before, these educators are there to guide you in a way that is efficient and effective. And if you are spending your time in Unacademy's classes, then just be rest assured that your time will be well spent, and it will be well spent in you, and it will just make you score good marks. So that is the main aim that these educators are going to just teach you with. And there are multiple educators for a single subject also, so there is also a nice option for you to just choose the educator or the teacher which resonates with you the most, and just attend his or her class. So another good thing for the Unacademy subscription, another plus point which you can take advantage of. And new subscription prices, Unacademy's prices are listed here if you are going to select the plus subscription plan. And as you can see, a lot of options are provided, so that you can choose according to your need and budget. And the best plans here that I would just like to inform you are 12 months, 18 months, and 24 months plan, because the amount of discount offered if you select these plans are far better than the rest of the plan. And the plus subscription type which you can see here is for those who need classroom type experience, where you are going to study with other students just like in a classroom. And if you want, just see, first of all, just see the prices. They are very reasonable. You can just compare them with any offline or online classes, and just compare the content that Unacademy is offering, and the options the Unacademy is offering. And also this includes test series which easily cost thousands of rupees, and they are regularly updated, and a detailed analysis will also be provided. So just compare the website, the tools, the content, and you will see that these prices are very much worth what they are providing. So if you want to get more discount, extra discount, then use the code which is listed on the, or which is written on the left side of the screen, that is 10% off code ABHIMI in all capital letters. And you can just select this subscription plan and pay the prices by selecting no cost EMI, which is available on 6 months and above subscription plans. So this is the final discounted prices and the least possible price by providing, or least possible price in which you can get this Unacademy subscription for. And this is the code which is making this least possible price possible. And this ABHIMI code you can just see if you are entering this for 12, 18 and 24 months, the amount of discount you will be getting is more, because 10 percentage of those will be accounting to a lot of savings. So if you are not sure that the Unacademy is right for you, then you should just go for 1 month. You can always do that and just pay for it. And then if you are thinking, if you are just seeing that it is good or not, if you are thinking it is suitable for you, you are having a good time studying with Unacademy, then you can also go with more months after that, extend your subscription after that. But remember, by using this code and paying for more months from the start, you will be getting a lot of discount, which is always the best thing. And 12 months you can take, if even if you are preparing for GATE 2021, because of the fact that you will be getting this, you will be needing this resources even after you have given GATE examination, for interview preparation and some other exam preparation like BARC and ISRO and things like that. And plus subscription is one of the types that we have discussed, and the other type is Iconic, which is for those who need more assistance. And here you can see 12 months and 24 months plans are available. And again, this 12 months and 24 months plans, which you can use the same code here, ABHIMI, to get 10% off here also. And the prices here are very reasonable for the Iconic subscription type, because again they are providing personal assistance, personal coach, personalized test series and things like that. And the prices are very proper for the content and for the assistant that this subscription plan is providing. So these are the benefits of Plus and Iconic in your screen, and this is the final slide. After this we will start our class. And again, 10% off code is capital ABHIMI. Use this, select at least 1 month plan and see that what you can take advantage of, and just subscribe to Unacademy and just start your preparation. And again, Iconic if you want more assistant, Plus if you want classroom type experience. But remember to just start your preparation by using this, because you will ultimately find yourself in a very better position if you are preparing from a quality source. And Unacademy is one of the quality education platform you can find anywhere on the internet at this moment. So let's start this class. So here is the first question that we will be doing for the day. So in this question, in a single pass drilling operation, a through hole of 15 mm diameter is to be drilled in a steel plate of 50 mm thickness. Drill spindle speed is 500 rpm and feed is 0.2 mm per revolution, and drill point angle is 118 degrees. Assuming 2 mm clearance at approach and exit, the total drill time in seconds is asked. So this is drilling question, first drilling question that we are going to do for the day. And in this question we are first of all provided with this data or this detail that a single pass drilling operation is occurring and a through hole is being made. So what is through hole? So through hole is a hole which is equal to the thickness of the workpiece itself, and blind holes are those holes which is having thickness less than the thickness of the workpiece, so you cannot see through that hole, therefore the name blind hole comes from that. And again, 15 mm diameter is to be drilled in a steel plate of 50 mm thickness. So thickness and diameter are given, and drill spindle speed is 500 rpm. So That is one thing that you have to take into account here, because that will be required for calculating the drill time. And feed is given and drill point angle is given. So why drill point angle is given here? Because the question is expecting us to calculate the compulsory approach. And what a compulsory approach is, so what will happen is, let me draw a rough figure here, that this is your workpiece and you have to make a through hole here. So you are going to use this drill bit to make this hole, and the compulsory approach here will be the distance. Okay, the compulsory approach x will be the distance, after which full length of or full diameter will come into contact with the workpiece of the drill bit. So this drill at the starting, when it is having its first contact with the workpiece, it is not having its diameter, full diameter in contact with the workpiece. It is just having its tip in contact with the workpiece, and as it moves forward to make the hole, more and more amount of diameter will come into, or more or increase in diameter, increasing diameter will come into contact with the workpiece till the full complete diameter comes in contact with the workpiece. So that length is this much. You can easily see that from the figure itself. There is nothing again very high conceptual thing going on. So this distance is x, and this x I should write it like this. So this distance is x, and this distance right here is the compulsory approach. Means after this distance only the drill will be having its full diameter in contact with the workpiece. So you can obviously see why this is necessary, because you want to just make the hole of a specific diameter which is equal to the drill diameter, or which can be more than drill diameter also, because we can do after drilling boring and things like that to increase the diameter, but it needs to be having a specific diameter, which will only happen when full diameter of the drill will come in contact with the workpiece. So this x is the compulsory approach. So let me write it here. And x is equal to 0.5d and 0.3d. So x is equal to 0.5d for through holes and 0.3d for blind holes. And what blind hole and through holes are, I have already discussed with you just when we were starting doing this question. So here we have to take the compulsory approach as 0.5d because of the fact that through hole is given in the question. So that will be the thing that you can just look into. Let me give you one more information. So let me provide you one more detail here. So what this approach and clearance at approach and exit means is that this is your workpiece and this is the hole that you have to make here. So your drill could be like this. So this is the clearance provided at approach, and it can just after doing the drilling, it can just be ending it at this position. So this is the exit clearance. So these values are also given. So I hope you have now understood what are the meanings of this clearance at approach and exit and compulsory approach, and why we are taking it into account. And because the drilling time will not only be depending upon the thickness of the hole, but it will also depend upon the other distance or other length the drill bit has to cover, and that length we have just just I have shown what those other lengths are. So the effective length of that a drill bit has to cover will be the thickness of the workpiece plus approach plus over travel, which is basically clearance at exit, you can take it like that, over travel. And this is must, because if approach and over travel is not given, then obviously we will not take that, but we will always be taking this compulsory approach x, which is basically, I am telling again, is the length after which the full diameter of the drill will come into contact with the workpiece. So thickness is given in the question as 50, approach and exit clearance is given as 2, so let's take them 2, and compulsory approach we have being provided with drill bit angle and the detail that through hole is there. But since drill bit angle is provided to us, so what we have here is this detail, this not drill bit angle, the drill point angle, so this 118 degree we have here. And now I think we can calculate this x from this information. We have diameter also, so from here what we will find is that the x, that is compulsory approach, is in this triangle. You will see we have this angle as 118 divided by 2, so that will be 59, and tan 59 will be tan point angle divided by 2, so tan 59 degrees will be equal to the perpendicular, that is d by 2 divided by this x that we have to find. So from here x will come out as 15.02 millimeters. So that is the value of x which is coming out here. And again, let me just so the diameter was not 50, it was 15 mm. So I think we have to just make that do this correction here. So it will be tan 59 and 7.5 divided by this 4.5, it is coming 4.50. so this is the value of x, it is coming in mm. So again we have two ways to calculate this compulsory approach. First we have discussed it that 0.5d is the compulsory approach for through holes and 0.3d for blind holes. But since here we have been provided with the details and the information by using which we can calculate this compulsory approach from the drill point angle and the diameter and the figure that I have drawn at the top region of the screen, you can have your compulsory approach calculated as 4.5. so what will be the effective length here? It will be 58.50 in millimeters. So now we have found out the effective length. So the drilling time will be, the machining time or drilling time will be effective length divided by Fn, where F is speed, N is the drill rotational speed in RPM. So let's find what the answer will be. So in seconds we have to provide the answer, and it is coming out exactly as what is given in one of the options. It is coming out as 35.1 seconds. So here you have seen one very important thing, and that was the reason this question was included, and that thing was that here the compulsory approach should not be taken as, I am writing it at the top, it should not be taken as 0.5d, even though for through holes it is 0.5d, because we first will calculate compulsory approach using this figure of the drill, and here point angle is given. So if point angle and diameter are given, then we will be finding out the compulsory approach like the way we did in our solution. And if those things are not given, if point angle is not given and only diameter is given, then we cannot find the compulsory approach using the geometry of drill. So what we will do, we will just follow the standard, that is 0.5d is compulsory approach for a throw hole, and 0.3d is the compulsory approach for a blind hole. So you have provided with these two approaches, and select the one according to what are the informations provided to you and according to the situation. And again, if you used the 0.5d for through hole to calculate the effective length, then what you will find is that your compulsory approach now come out to be 7.5, and your effective length becomes 61.5, and therefore your answer will become 36.9. So that is obviously not given in the options, so you are going to just check what you are doing wrong and you may then correct it. But if this is a filling the blank subjective type question, then you can make this mistake and you can just write the answer there by just calculating the compulsory approach wrongly. So just remember this thing, that if drill point angle is given, then use the geometry to calculate the compulsory approach, not the assumptions that we have taken, that is 0.5d for through hole and 0.3d for blind holes. So that will be it. I have taken a lot of time in this question because the reason is clear. We will do a question and we will be covering all the things that we can learn from them, and we are not only here to solve a question and move on, we are going to analyze it and we are going to see if we can learn extra things other than what is uh, generally the solution of a question teaches. So here we have learned those things, and we will all, I am again taking a look to see if I can share any other information here. So that will be it. And again, drill point angle, remember, if you are not going to draw this geometry, then always remember to calculate compulsory approach, we are taking half of that drill point angle, because that's how the compulsory approach can be calculated, because of the triangle there. And again, in this question it is given, I will just remind you once more, because these are some of the common errors that a student makes. Since this is the objective type question, so you can clearly see the answer, but if again this is subjective type question, so you can make this mistake of just writing the answer in minutes, because when you because in majority of the question the time is asked in minute on, and also in your formula the time is by default calculated in minutes. So you have to be very careful when answering this machining time or drilling time, that you are just giving the time in correct units or not. Basically seconds and minutes are the only two units which are going to be in which the answer is going to be asked in, and you have to just check if seconds is the one in which you have to provide the answer, or if minutes is the unit in which you have to provide the answer. So now we are ready to move forward and just do the next question. Again, these are the questions which you should just write it down if you want. Good question for revision, covers a lot of things. So the next question is, a drilling machine is to be designed to have 6 spindle speeds ranging from 110 rpm to 650 rpm. Assuming a proper series for the layout of the speeds, determine the value of all those spindle speed. So we have to calculate 6 spindle speeds. This is a conventional question. So those 6 spindle speeds have been asked to you, and we will calculate them one by one. But in your gate examination, you will be only going to get asked one spindle speed, and so it is good that we will calculate all the spindle speed, because gate question when comes from this particular topic, that is spindle speeds range, or different spindle speed values, then a question easier than this will come, not harder than this. So we will be doing this proper full question, and a part of question, this question might get asked. So let's do this question solution. So drilling machine is having 6 spindle speed. So this spindle speed will be following GP, geometric progression, with the R as under root of, and this under root is the n minus 1, and here we will have the maximum speed, and here we will have the minimum speed, or let me just write it like this. So again, here n is the number of speeds a spindle can have in this arrangement, and here 6 spindle speeds are the thing that is given. So n will be 6, so n minus 1 will be 5. So what we will find, that this R, which will make us give the other speeds in this geometric progression, so this R will be so this is coming out as 1.426. So we will take it as 1.43. So this is R, which will give us other geometric progression series values, or therefore which will give us other speeds. So n1, which will be the minimum speed, is 110 rpm. n6 maximum speed 650 rpm, and the rest of the speeds will be calculated when we keep on multiplying this n1 with the R, which will give us a geometric progression series. So n2 will be rn1, so this will be simply 1.43 into 1110, so 157.3 rpm. n3 will be r square n1, so this will become 224.93, so let's take it as 225 rpm. And n4 r cube. So a easy way to remember here, let us discuss that after we have done calculating all the speeds. So again, 1.43 cube into n1, so this will give us 321.66 rpm, and n5 here is r raised to the power 4 into n1, so this will be given to us as 456 rpm. And if we multiply 1.43 with this again, we will be getting around 650 rpm. And since we have taken a little bit of approximation here, therefore the values are coming a little bit different. So again, a nice thing that we can learn from here is that because the n6 is coming out as 657, but it should come out as 650. So let's do one thing. Let's just use 1.426 and calculate the. So if we use 1.426, which is basically the value of r up to 3 decimal places, then our n6 is coming out as 648.6. so that is more closer to the 650 than 657. But again, here one thing you can remember is to take this r as accurate as possible. Don't make the rounding off, and don't make it just do the calculation by taking approximations, because here you have to find this rotational speed in geometric progression, and a lot of multiplications are involved. So the error, if you make a assumption, or if you make rounding off, then after multiplications the error will be quite large. So again, in GATE examination you might get asked about n5, n4, n3. So one of the speeds you might get asked, and not all the speeds. So what you can remember here is that to calculate n, where n can be 4, 5, 6, 7, you have to follow this root approach, that is this r raised to the power n minus 1 into n minimum, or n1. So for example, if you have to calculate n5, then it will be r raised to power 5 minus 1 n1, so this will become 4. So one less than what speed you are calculating. And again, a good question to just know about, because you should know here that the series that the spindle speeds are following is a GP, geometric progression type of series. So if you know that, then you can solve this question. But still, it is better that you know, since this is from our syllabus, so it is better that you know how to solve this type of question, because if you don't, then you can, even though you can do this, you can take a lot of time in just understanding how to do this question. And again, even after you do that type of question, you might be thinking that it may be wrong. So it is better that you know even the simple questions properly, because you can be confident when you are doing them. So again, each and every topic, it is must for you to just go through them at least once, so you can be confident in your approach, even 50%. So that is more than being just zero confidence and not knowing how we can do a question. So let's move forward and do the next question. So direction is given. So basically this question, this information we are provided with at the top of the screen will be used to solve two questions. And the first question is machining time calculation per hole in minutes, and drilling question again, because we are doing the drilling topic today. So blind hole 10 millimeter diameter. So I have done one of the through holes question where we discussed that. Now we are doing a blind hole question. So we are covering as much as we can in this classes. And blind hole, again, I hope you know what is the compulsory approach for blind hole, because it might be coming in use. And here, as you can see in the question, we are not, no, we are provided with drill bit angle, so that will be not, we will be not using that assumption of compulsory approach just by seeing blind hole and through hole. Still, for blind hole, remember what is the compulsory approach. I have just pointed, just mentioned you before. So if you are watching this in a recorded, as a recorded class, then just remember. And I'm going to just give you that answer. It is 0.3d. So remember that 0.3 for blind hole. You can remember this from the fact that blind hole will be having less compulsory approach because it is not making full thickness. So this is not some conceptual thing, this is just for you to remember a trick. And now let's move forward and see what are the other datas provided. So 50 mm deep is the workpiece or the blind hole, and therefore the thickness is 50 mm. And drilling, so the thickness of a workpiece will not be 50 mm because it is blind hole, so it will be the depth of the hole. So remember, blind hole is not having the thickness equal to the workpiece. And drilling speed is 600 rpm, feed is 0.2 mm per revolution, point angle of the drill is given as 120 degrees. So since point angle is given, and I have taken a lot of time in just making you understand this, then when point angle is given, we will be using that and the diameter of the drill to calculate the compulsory approach. And here we are not being provided with overrun and the approach which a drill bit has to travel to come into, for strip to come into contact with the workpiece. So that information is not given, so we will neglect them. But we cannot neglect compulsory approach because we are provided with the information by which we can calculate that compulsory approach. So let's calculate the machining time, but before that let's calculate the effective length the drill bit which has to cover. So effective length will be the thickness of the hole or the depth of the hole, which is 50 mm, plus the compulsory approach. So the compulsory approach can be calculated as again I'm drawing the figure here. So let's erase this thing and first calculate compulsory approach. So for compulsory approach, for x, always make a habit to draw these figures. It will not take a lot of time, but again you can see if you are drawing a figure, and we have discussed in some questions that how silly errors you can make, and how you can avoid them if you can just draw a figure. And we have more specifically in one of the question, let me just give you again, remind you of that. When we are doing the tolerance question where we have to calculate the maximum size or minimum size of something, and if, for example, if for a pin or a shaft, if plating thickness is given, then if you draw the figure and calculate the maximum size after plating, then you will see that you are going to make less error than you can then as compared to if you are just not drawing the figure and just making the calculation. So there a potential can come that you can only add the thickness once for the maximum size of the shaft, but you have to add it twice because that's how thickness accounts for diameter. So here this is 90 degree, and this is diameter by 2, this length which will be using here, and this is the compulsory approach that we have to calculate. So compulsory approach from this figure can be seen as 10, and here is the point angle, let's take that as alpha. So point angle is given as 120 degrees, but we have to just used half of that point angle, because in this right angle triangle ABC, that is the angle that is coming into just play. So it will be tan 60 degree equal to the perpendicular divided by this base. So from here x will come out as 50 will be the thickness or the depth of the hole, and x will come out as d by 2. So 5 divided by 10, 60. So we will be getting 2.88 as the value of compulsory approach, and it is coming out 2.8867. But let's take two decimal places only. Let's not complicate our solution here. So it will be 52.88 mm, and after that we can easily calculate the machining time. So it will be effective length divided by this Fn, which will be the axial speed. So 52.88 divided by the feed is 0.2 mm. Always confirm is the feed is given in mm. It is usually given in mm per revolution, but always confirm that the units are given in a single form or not. If it is given in centimeter, then make sure that you are converting all the units into mm or centimeter, because again that some of the questions that you can see in your previous year GATE examination or test series, this type of things get asked to trick you, to make you do error. But again, if you are just aware of the fact that this type of things a examination can do, so you can always check them and confirm them that you are doing the question correctly. So 0.2 is the feed, and spindle speed is 600. So from here we are getting the answer as 0.44 in minutes. So here is the answer, 0.44 in minutes. And I have taken a lot of time in discussing that you have to be properly taking care of the unit in which you are answering machining time. In this question we can see have been asked the unit of the answer in minutes, but in the question that we did just when we started our discussion today, the question was asking us the time in seconds. So again, you have to always check this thing, since this is a objective type question, so you are not likely going to make mistakes, because you will be seeing the options and just reminding yourself of the unit in which the question is asked. But if the question is provided in filling the blanks type question, or if you have to just write the answer there and no options are there for you to just look into, then you can make this mistake. And I am again pointing these things out a lot, because these are the errors that a student can make, and these errors are students have made this type of errors, therefore I am just pointing this thing out. Again, my job here is to make you remind of all these errors, make you be aware of all these errors, and the rest will be up to you, how much you are making using the knowledge that I am sharing with you. And I will be doing this in a relaxing manner, because this class, as I have discussed before, we are going to attend this class in very calm manner. We are not going to just shout and just move forward, and I will not tell you to just read the formula day in day out, because that's not how you should be approaching. Again, you can approach that way, you can good marks, but what is the fun in doing that type of study? The fun is learning smartly, and just knowing about all the things that you have to avoid and you have to follow to score good marks. So let's move forward and do the next part of the question. So the next part here is asking us that the above information is same, so the question remains same, so the information remains same, but the question now changes, and it is asking that during the above operation, that is during the operation in which we are creating blind hole, the drill wears out after producing 200 holes. So this line right here, drills wear out after producing 200 hole, is just providing us this information that the drill life is 200 holes, and Taylor's tool life equation is of the form Vt raised to power 0.3 C, and where V is the cutting speed in meter per minute and T is the tool life in minute. So Taylor's constant C will be, so we have to just provide the Taylor's constant C in the equation v t raised to power 0.3 is equal to C. So again, not that hard of a question. We will do this very quickly. So what will be to find this Taylor two life equation, we have to be knowing about the other parameters here in the equation. So we have to be knowing about v, that is velocity, and t, that is the tool life. So since tool life is given as, or since the tool is given as the one which can produce or which can be used till 200 holes creation or production, so the tool life we will have to calculate it, and we will use this logic here, that tool life is equal to 200 holes into machining time, that is time per hole. Time per hole and time per hole is the machining time. So the machining time will be, we have calculated the machining time and it came out to be 0.44. So the machining time will be 0.44. So 0.44 into 200. So we will be provided with, we will be then getting the tool life. So 200 into 0.44, it is 88 minutes. So 88 minutes is the time after which the tool will just not be usable. So we can use the tool till this 88-minute duration. And optimum velocity, how to calculate that? We have been provided with this speed. Not optimum velocity we have to calculate, we have to just calculate the velocity for which this tool life is 88 minutes. So we are not going to provide optimum velocity. Sorry for the optimum velocity mentioned there. So again, that velocity can simply be calculated by this pi dn, and that will give us the velocity equal to pi into d is 10 mm and n is 600. So if you are watching this session live, always just make yourself just engaged in the class by providing the answers in the comment section. So it is coming out as 18.85 meter per minute. And why we have calculated the velocity meter per minute and not in meter per second or mm per minute? Because in Taylor's tool life equation, always remember that, again a very important thing that I am going to discuss right now. In Taylor's tool life equation, always remember the unit of velocity is meter per minute and the unit of time is in minute, because that's how the C can be calculated. So this is the, by default we have to take into consideration this thing. So now the C will come out simply from the equation, we can calculate C. So it will come out as 88 raised to the power 0.3 into 18.85. So it is coming out as 72.22. So C is coming out, when we have written all these things, the C will come out as 72.22. So B will be the correct answer to this question. So that will be it for this question. And now let's do the next question. But again, before moving forward, let's see if we have if we can still learn some new things from the question, from this question that we have just solved. So in the first part, we can see that blind hole is given in the first part of this question, and drill angle, point angle is given for the drill, which is 120 degree. So we are going to calculate our compulsory approach, which by the way is the distance which the drill has to travel so that its full diameter will come into contact with the workpiece. So that compulsory approach we are just finding using this figure, this drill geometry, and that came out to be 2.88 mm. And then our effective length will be how much deep the hole is, and how much compulsory approach the drill has to travel before it just does the machining. And the effective length is coming out as 52.88, and after that we calculated the machining time properly. So here always remember, when you are providing the answer, in which unit you are just providing the answer, and which unit the question is asked you to give the answer in. And if point angle is not given, so if point angle is not given, then how you will calculate compulsory approach? So let's assume this detail is not provided to you. Then how you will calculate the compulsory approach? You will calculate compulsory approach for blind hole by using this assumption that we have gone through in our theory, that blind hole compulsory approach is zero point 0.3 into the diameter of the hole. So we will use that here, and if you are using that here, what will be the compulsory approach? It will come out to be 3 mm, which is quite equal to what we have calculated by using this geometry. So again you can see why this 0.3d is taken as an assumption, and why we have to study this, because it is nearly giving us the value that we have calculated from this geometry. So if point angle is not given, then we will use this basic standard assumption, but we are not going to use this in this question because point angle is provided. So another variation I have just taught you here. And the next part here is asking us for Taylor's constant in the Taylor's tool life equation. And again here it is given in the question itself that cutting speed is in meter per minute and Taylor tool life is in minute, but sometimes this thing will not be provided to you, because this is the again the basic standard thing, that when you are using Taylor tool life equation, you should know this thing, that cutting speed there is always in meter per minute and tool life is there in minute. And that will be it for this question. And how we calculated tool life is quite simple. We know what is the machining time of one hole, and we just multiplied that by the number of holes the drill is producing before it wears out. So that comes out to be 88-minute tool life, and we just use that here to get our answer. So this questions again, we did some nice discussion here, and I hope if this type of question gets asked in your GATE examination, you can solve it. And let's just do the next question here. So let's do this question that is right here coming in our screen. So in this question we are uh, given this information that a 15 mm diameter HSS drill, and what is HSS? It is high speed steel, which is having, again we will do revision here, which is having 1841 as the constituents, where 18 is the tungsten, 4 is the uh, chromium, and 1 is vanadium. So 1841 HSS high speed steel drill is used at cutting speed of 20 meter per minute and at a feed of 0.2 mm per revolution. Under these conditions, the drill life is 100 minutes. The drilling length of each hole is 45 mm and the time taken for idle motion is 20 seconds. And the tool change time is 300 seconds. calculate the number of holes produced using one drill and average production time per hole. So we have to calculate two things. We have to calculate the number of holes that we are going to produce using this one drill, which is for which the information is provided here, and drill life is also provided 100 minute. So previously we have been provided with the number of holes and we calculated the drill life. The we have been provided with number of holes and we calculated the drill life there. So it came out to be 88-minute tool life. You can see here in our solution. Now we have been provided with drill life, which is 100 minute, and we have to calculate number of holes that drill is making. So average production time is also the thing that we have to calculate after our calculation of number holes. So that average production time will include all this tool change time, idle motion, and we have to calculate that for per hole. So another nice question, one of the parts can get asked in your GATE examination, or both parts can be asked in two-part question. So let's do this, and we will do this very quickly because till now I have taken time which I think was necessary, because I have gone through this we have gone through this question in detail here. And the reason that I am taking time, because as mentioned before, these classes will be self-contained. If a student is coming into one of my class without the previously attended any of my class, he or she can attend the class and get all the information and understand the discussion there going on properly. And so self-contained class, therefore I am taking time. And if you have watched my lectures before, then you should know a lot of things from that discussion, but still we are doing new questions here, so it is worth attending again if you want to do this new type of questions without having to go through the GATE books and previous year question paper and finding the questions there. So I have done all that work and selected the best questions, and let's do this. So number of holes we have to calculate. So to know how much holes this drill will produce, we have to know this thing. We have the drill life, that is 100 minute, and now we have to know the machining time of one hole. So drill life divided by the machining time for one hole will give us number of holes, and we know 100 minute as drill life. We have to just calculate the machining time of one drill, not one drill, one hole, and that can be calculated by this formula, again using this formula for the third time today, but for different purposes, different end purposes. So effective length, what will be the effective length here? Let's quickly do this thing. We are not provided here the point angle. In the previous two questions we were given point angle, but here we are not being provided with the point angle, so we cannot find the compulsory approach using the geometry. So we have to use one of the assumptions. We use one of the standard assumptions that we have just studied. So again, let's see if the question is asking us for the holes are blind hole or through holes. So here we are not being provided with the thickness of workpiece or thickness of hole. So we cannot just be 100% sure. We cannot say that this is blind hole. So by default we will take this as through holes, because if it is not being provided that length of hole is less than the workpiece length, then by default it is understood that the hole is having equal length, equal depth, and equal depth as depth equal to the thickness of workpiece, simply that. So for through holes we will have this thickness or length of hole as 45 mm, and we have to find we have to just add the compulsory approach will be for through holes d by 2, that is diameter into zero point 0.5, and therefore that will give us the effective length. And what is the feed? It is 0.2 mm and per revolution, and the rotational speed here is not given, so we will calculate that by just using one of the relations which relate the diameter, velocity and rotational speed. So n be calculated using this. V is equal to pi d n, and here d is in meter per minute, or we can convert the v in mm per minute. So let's write d in meter, and this will be in meter per minute. So from here n will come out as, what will be the value of rotational speed here? The velocity given is 20, and we will divide it by pi and divided by d, which is the diameter, which is in meter 0.015. So it is coming out as 4 to 4.41 rpm, and we have to multiply that with zero point 0.2 and divide that with the effective length, which is 45 plus 7.5, and now our answer will come out as 0.618. So let's take it as 0.62 minutes. So that is the machining time for one hole. And now we have to calculate number of holes. So total life divided by machining time for one hole, 0.62. So this will give us the number of holes as 161.29. So since this is not a whole number and we have to calculate number of holes, so we will say that number of holes produced is number of holes produced is 161, because one hole is not produced in full manner. So the number of holes that are produced, if we are using this drill of having drill life 100 minute and using that at this speed and this feed, then we will be getting 161 holes produced. And now this first part is done here, and again we have used the standard assumption to calculate this compulsory approach, but compulsory approach must be added there. If you have not added there, then your answer will be a lot different. What your answer will be, let's see that also. If you are not adding compulsory approach, then your machining time for one hole will come out to be 0.53, and therefore your final answer will become 188.6. so it will become 188 holes, so that will obviously be wrong. So compulsory approach, as the name suggests, it is compulsory and you have to add this. You have two ways: point angle you can find by geometry, point angle not given. Follow the basic assumption standard formulas to calculate them: 0.5d for through holes, 0.3d for blind holes. If blind holes and through holes are not given in the question, which hole is the drilling is done and the drilling is making, so you have to calculate for through holes by default, because by default it is we are taking it is we are just following this concept that the holes depth will be equal to the depth of the workpiece. So that are the things that we studied here, and now we will calculate the average production time per hole. So let's find that average production time per hole, and we have to do that in a new page here. So let me add a page. So let's do the second part of the question. or let's just erase this and continue our discussion there. So what will be the average production time per hole? So per hole is the thing that we have to just take notice here and then do the question. So what are the times that are given? Drill life is given as 100 minute, and the rest of the things that are given is idle motion 20 seconds, and the total changing time is 300 seconds. So for one hole, the machining time is 0.62. So what will be the average production time for them? So it will be so we are provided with machining time per hole. We have calculated it, not provided it. 0.62 minute. The idle time as 20 seconds. So let's write it down in minute. It will be 20 divided by 60. So 1 divided by 3.33 minute. And the tool change time, so TC 300 seconds, so 5 minute. And tool change time will occur after your tool life has reached or tool has to be changed. So that thing you have to just remember here, that we are going to use the tool change time after your drill has been worn off, and therefore that thing you have to take into account, and a portion of that will be going to the average production time per hole, not whole 300 seconds. And idle motion is given as 20 seconds. So again, let's see. So your average production time will be this 0.62 plus idle motion. So this idle motion is for each hole, because again the drilling time for each hole is 45 mm and time taken for idle motions is 20 seconds. So this is not for the whole lot of your holes. This is just for one hole. So for one hole we are calculating these things, and 300 seconds is for the 161 number of holes. So 5 divided by 161 will give us the portion of that tool change time that will be taken with this other times, so that we can get average production time per hole. So that will be 5 divided by 161. So we are getting our answer as 0.981. So let's just write it as 0.98 meters. So this is the average production time, and here you have to just remember that the tool change time is for the 161 or total number of holes, because after those holes are produced, then after we are going to change the tool, and then after the tool has been changed, after this 5 minute or 300 seconds, we will move on to our next batch of producing holes. And this idle motion is 20 seconds, but this is for this is after we have produced one hole, we will do this idle motion, then we have produced one hole, then we will do idle motion. So this idle motions in which drilling is not going on will be happening again and again when we are producing a new hole. So therefore we have to take this, add this value for this production time of one hole without dividing it by the number of holes, because this will be happening every time we are creating new hole. But the tool change time will only be happening when we have calculated when we have drilled 161 or total number of holes, and the drill has now worn off and it needs to be changed. So therefore we will do that 300 seconds tool change time. And therefore I hope you have understood how we have calculated this average production time and why we have divided this 5 minute, that is 300 seconds, with 161, not the idle time. So that is again one of the very good questions, because you can make an easy mistake and not calculate the time properly if you are not following or not understanding what the question is asking. So let's move forward and do next question. But before doing that, let me just provide you with one more small detail. So I think we have discussed all the thing here. I thought I have to tell you one thing, but that is not the case here. We have discussed here, uh, and we found we just discussed one extra thing, that high speed still what it is. So it is 1841, and I have discussed that here. So let's move forward. So the relation between tool life and cutting speed is Vt raised to power n is equal to constant. So we know Taylor's tool life equation is this. In this relation, the value of n depends on. So what the value of n is depending upon in this relation? Is it depending upon work material, tool material, working conditions, type of chip produced? So let us just see this T raised to the power n is equal to C by V. So this n is different for different type of tools. And let me give you the answer first, then let me show you one graph so that we can properly understand why this n is depending upon, that is the answer, tool material. So this n in the relation of Taylor's tool life will be depending upon tool material, and why? Oh, I think I somehow just wiped that out. and we have to do this again. So let's make that little bit of figure again. So these are some of the things that PowerPoint needs to be addressing. Why it got wiped out when by mistakenly I pressed one of the arrow keys or something like that. This is the Taylor two-life equation. So this graph, this lines are for different tool material. For one we have first line HSS, two we have carbide, and three we have ceramic. And if you just take log in this equation, then what you will be getting is log V n log T is equal to C, constant. So log V is related by, or log V divided by log T will be equal to C by, or that we cannot take because they both are coming as a product in one side of equation, and here I have to take log C, which will not be that much of concern because log C is can be also taken as a constant K. So here is the equation right here, and the log V and log T graph is shown in the figure, and for the variation of log V and log T, we can see that the steepest graph is for the one, and second and third is not having that steep graph. So therefore from this you can just see that they are there is something in which, by which, or independence of which this graph is getting changed, and that thing is relating, or that thing is depending upon this materials, the type of material. And high speed still is basically uh, so a tough material, not that hard, and carbides and ceramics are the tough ones, not tough ones, the hard ones. So in this figure that I have drawn here, you can just look and see that this n will be different for this different material, and due to this n being different, these graphs are coming out to be different. Let me just mention here one more thing, that n will be maximum for this third, that is ceramic, and therefore that that will just let us know that if n is maximum, this slope is coming out as not that steep, therefore this slope must be inversely proportional to n. So our answer here will be that the log V and log T is depending upon the inversely, the slope is depending upon the inversely with the n. So here I hope what I wanted to understand or tell you was clear, and I think that got erased again. So here the n will be depending upon tool material. Why? Because for different tool materials n will be different, and therefore they will give different value of this tool life or velocity if one of the value is given and another you are calculating. So that will be it for the discussion of this question, and let's move forward. Thrust force in drilling can be reduced by, and the point angle, yes. So thrust force in the drilling can be reduced by dash the point angle. So here there should not be this comma coming. So thrust force can be reduced by reducing the point angle. So if we have reduced the point angle, then the thrust force can be uh, reduced, and the helix angle, it can be reduced by increasing so basically from this we can just get this information that the point angle, that is this angle, if it is getting reduced, then the force will be reduced. So this is the point angle, and here we will have some helix, and the angle which this is making, this slant is making, is the helix angle. So when that angle will increase, and that angle, you have to also remember here that thing, that there is one more angle in drill, that is your rake angle, and which is equal to 0 at the center, and as we go towards the periphery it becomes equal to helix angle, and that rake angle is inversely proportional to point angle. So rake angle here in drilling is inversely proportional to point angle, and since that rake angle is becoming equal to the helix angle at the periphery, so we can also say that this helix angle at periphery will be inversely proportional to the point angle. So from that you can have this information that if the point angle is reducing, your helix angle will be increasing, and for thrust we need the point angle to be reduced if the thrust force is to be reduced, and therefore by this information that we have discussed, we can just come into this conclusion to, if that is happening, then helix angle will increase. Helix angle of fast drill is normally. So there are three type of helix drills that we have to just study for our gate examination, and one of them is fast, and for fast drills helix angle is normally 35 degrees. So that is one thing that you have to just remember. There is a, you cannot just answer this question from logic, because this is one of the standard values that you have to remember. So we have this three types of helix drills: slow helix drill, regular helix drill, and fast helix drill. So slow helix drill will have this helix angle 12 to 22 degrees, and regular helix drill will have 24 to 32 degrees, and fast will have 34 to 38 degrees. So maximum helix drill angle 38 is going on among this three. So in this the correct value will be 35, because this is coming inside our range. So the correct answer will be 35 degrees. Tree panning is performed for. So tree panning is basically the process in which we are creating hole but without drilling. So what we will do is we are just cutting the region, and we are doing that such that a through hole is provided. So only through hole can be provided in tree panning, because we are cutting that region instead of drilling. So that region will be cut and the section will have hole there, but no drilling operation can be performed or is performed in tree panning. So tree panning is performed for producing a large hole without drilling. And this is the final question for the day. So let's do that and end our class. So let's see what we have to find in this question. So first, I am just reading about the first point, that is Taylor's tool life exponent and constant we have to find, and then we have to find optimum cutting speed. So we have to do this two things to calculate. We have these two things to calculate to get the answer, and this is from the GATE conventional questions. So again, standard question, because this already came in one of the official GATE papers, but as a conventional one. So let's see what we have to do here. So tool life in drilling steel using HSS drill is expressed as, oh, so I have not written here one of the equations. I think I forgot that. So let me just write it down. Let me just see where the question paper is. So I have the question with me. Apologies for not writing the question. I somehow forgot that, because this I have to write it by changing the text to equation, and I thought I did that, but no worries, we are going to do it. It is very small equation. So t raised to power 0.29, and I should write not the equation here, because then my video field will block it. So let's do that in the top region. So this is the equation that we have to just see here and use to find the tool life. So tool life in drilling steel using high speed steel is expressed as this equation, where d is the drill diameter in mm, t is the tool life in minutes, v is the cutting speed in meter per minute, and s is the feed in mm per revolution. The feed is set at maximum possible value of 0.4 mm per revolution for the given drill diameter of 30 millimeters. The length of drill is 50 millimeters, and the machine hour rate is, so the machining hour rate is it is given in the question is 60 rupees, and cost of drill is 400. So this is machine hour rate, or a early machining rate, I think it should be like that. So for the given conditions, the Taylor tool life equation exponent and constant are. So let me first of all have a blank slide here. So solution. What is Taylor's tool life equation? It is always given in this form. But we are provided with this equation, t is equal to 0 0.2, 9.8, d raised to the power 0.8, 0.4, and we have to divide this with v cutting speed and feed raised to the power 0.5. So let me check if this is the equation. So that is the equation we have to use. And from this equation, we can see that it is coming in this form of v t raised to the power 0.2 is equal to 9.8 d point 4 0.4 and feed is 0.5. So this equation and this equation can be related, and from this we can say that the exponent is zero point 0.2. The Taylor's two life exponent is 0.2. Why it is coming? It can be just seen after comparing. It will be 0.2, and what will be C will be this 9.8 d raised to power 0.4 and s raised to power 0.5. So this is a constant value also because diameter will not change, and feed is given with a maximum value as 0.44. You can see the question here also. I have with me question paper, so I was looking into that. So let's just calculate from here. So 9.8 into d is 30 and feed is 0.4. So it is coming out as 60.40. So this will be your Taylor's two life equation now. So it will be v t raised to power n is equal to c. So it will be v t raised to the power 0.2 into c is equal to c is equal to 60.40. So this is the first part of the question that we did, and it can be clearly seen. And again, very good question because you have to follow the basic concept, but this is asked a little bit differently than we usually do. So again, nice thing, and I think this type of question might get repeated because this question is conceptually you have to apply a very little logic, and that logic is easy, but still this question can be intimidating by just looking at this equation that is provided, which is not the one that we usually study. So gate used is just in the recent time is making this type of thing that it is asking easy question, but the length of the question is very much large, and the information that are given are sometimes extra, and sometimes um then there are assumptions also given. So this type of things is, you can see in the recent papers 18, 19 and 20, this type of lengthy question it's getting asked, and we have to remember that this lengthy questions are most of the times easier ones. So let's just continue our discussion of the next part of this question. So what is the next part asking? So let's add one more slide here. So the next part is asking us that optimum cutting speed, neglecting workpiece and tool changing time. So we have to neglect tool changing time, and we have one formula where tool changing time is neglected. So for that we have to find the optimum time for that optimum velocity. So T optimum, that will be T naught. If tool change time has been neglected, then we will be left with this n 1 minus n by n. But in this question we are provided with some cost, and that cost is machine hour per machine hour rate is 60 and the cost of drill is 400. So these two costs are provided to us. So let's see if we can use this two cost to find our answer. So what we usually do is we usually add this tool change time, and if this cost are given we add this also, but this is zero. We are said we have been provided this detail that we have to neglect them, and n is coming out, it came out to be zero point 0.2. So 1 minus zero point 0.2 divided by zero point 0.2. So this is optimum time, and after we have calculated this time we will use the Taylor two-life equation to calculate the optimum velocity, and we are given ct is this time is the ct, which is tooling cost, and this cost of drill is cm, which is 400. So this cost of tooling cost is 400, and machine cost per hour is your cm, which is rupees per minute machining cost. So the tooling cost will be 400 and machining cost will be rupees 60 per hour, so it will be 60 minute. So one thing you can remember, so that you cannot get confused, is that this cm is in rupees per minute, and this is simply in rupees, and this cm is machining cost, and this is tooling cost. So we are provided with this two cost, and since this machine hour rate is rupees 60, so this therefore this unit will be rupees 60 per hour. Therefore we can say that this will be cm, because cm will be having this unit, because if this unit is not there then we will not get the answer in minute, because this rupees and rupees will get cancelled, and the minute will be at the top, and therefore we will get our answer in minute. Therefore this cm should be at the bottom, and you can remember this formula by just that logic, applying that logic also, because again this is not a thing that get asked regularly, so you don't have to just go very deeply. Just remember this trick, that at the bottom you have rupees per minute when this costs are given, and you have to make use of them, and if neglecting tc is given, then you have to make use of this cost to find the optimum time, and then we will find the optimum velocity. So our answer here will be 400 into 0.8 divided by 0.2, so it will come out as 1600 minute, and we have this relation that we found out in the first part of the question. So we can now see that our answer is coming out as the optimum velocity is coming out as, for optimum time that we calculated at 1600 minute, 13.8 meter per minute, because that's what Taylor two-life equation gives the answer in for velocity. So we did these two questions, these two things that we were asked to do, and here again a nice question, gate conventional question. The first part is quite easy, the second part is also easy, because you have I think you have studied that how to calculate that optimum time when tc is not given in one of your theoretical notes. You can, one of your notes you can see that, and there we have this ct divided by cm, where cm will be in rupees per minute. So two cost here are given, and one cost is given in rupees per hour, so that cost will be divided by the ct width, or we can just take that cost in denominator, because we have to get our answer in minutes. So you can remember this by that. So that will be it. We can, I think this is the thing that we can learn from is this question, that again the question can be lengthy, but again the difficulty is not that much for lengthy question, because we are provided with all the data. We just have to apply a simple logic and solve the questions, and the lengthy questions are generally easy. I'm stressing this out again and again, so that you can, so you don't get panic or stressed out, or just skip the question, and just make this error when you come back to this question and realize that this is a easy one. So just that's it for today's class. I hope you found this class helpful, and engaging. So if you found this class those things, then hit the like button and subscribe to this channel, hit the bell icon for notifications. I will be coming live tomorrow at around 2 p.m. I will I just uh, the class today got delayed due to something, due to some work going on my home, so I have to change my setup, which you can see from the background of my video. But I will take into account that tomorrow, and make sure that I have proper just time. I will come in proper time, so that will be taken care. So again, thank you for watching. Hit the like button if you found this class helpful, and the 10% off code is ABHIMI. This code will give you 10% off when you subscribe to Unacademy. And again, subscribe to Unacademy at least for one if you are not sure that you would like Unacademy or not. So go for 1 month, and then after that you can decide if you want to continue or not. But start your preparation. This is the golden time, because in this time you will be giving your all because of the environment, because generally December and January are the times in which you study a lot, in which all students study a lot. And therefore you will get motivated by yourself, by on your own, and just give your test series, which are basically the most important thing, and learn from your mistakes. See what time management you can do. And Unacademy subscription also has this test series which you can give, and analysis of that will be provided. And my next class will be occurring tomorrow at 2 p.m., and we will be doing milling questions there. And after that we will be doing grinding questions, and after that we will be doing casting questions. And then we will do complete revision of certain topics. Like we will do casting complete revision in one class. We will revise all the formulas of casting, all the important things of casting in one class only. So that class will be quite long, but again we will make sure that we have revised all the formula correctly, all the things correctly, so that you can attend those classes. And just after attending those classes you can be well prepared. So that will be it for today's class. Again, thank you for watching. Best of luck for your preparation, and stay safe, take care. That's it for today's class.